The incredible AI that's changing our world, it didn't just appear out of nowhere. It's actually the result of this wild 75-year journey, a story filled with abandoned ideas, fierce rivalries, and breakthroughs that honestly felt like science fiction. Today, we're going to unpack that story. So, we're all surrounded by this amazing AI, right? But seriously, how did we get here? The answer is, well, it's not what you'd think. For decades, the smartest people in the world were basically on the wrong track. They thought the secret was just writing smarter code. Turns out, they were wrong. The real answer came from a complete shift in thinking.
And this quote from AI pioneer Tom Mitchell just nails it. For half a century, we tried to handcraft intelligence, line by line. But the real breakthrough, the game changer, came when we stopped trying to build intelligence and instead figured out how to let machines discover it on their own. And that is the story we're telling today.
Okay, so our story kicks off way back in the 1950s. The first computers are just humming to life, and a few brilliant researchers decide to take a crack at a problem that philosophers had been debating for centuries. How can something learn a general rule just by seeing a few examples?
And what's really incredible is how fast this brand new field saw its first big boom and then its first bust. In less than 20 years, two revolutionary ideas were born, and one of them came to a sudden, dramatic halt.
So, right from the start, you had these two pioneering programs that couldn't have been more different. On one side, you had Art Samuel's checkers program. It learned just by playing against itself over and over, and got so good it could totally crush its own creator after just 10 hours. On the other side was Frank Rosenblock's Perceptron, which was basically an attempt to build an artificial brain, a network that could learn by being shown labeled examples.
But then, a massive plot twist. In 1969, two MIT scientists published a book that proved, mathematically, that these simple networks had some pretty severe limits. They couldn't even learn a really basic logical function. The critique was so devastating, it basically killed neural network research for more than a decade. Just poof, gone. So with neural nets suddenly out of the picture, the entire field pivoted. The thinking was, okay, if artificial brains aren't the answer, maybe the key is something totally different. Maybe we should be teaching computers to think with symbolic rules, the way humans do.
And this was a profound shift. I mean, instead of trying to learn this messy web of abstract numbers that no one could really interpret, the goal now was to get a computer to learn clean, logical, human-readable rules, like a definition for what an arch is.
And this new era had some huge successes. A program called Metadendral, for example, learned symbolic rules to predict how different molecules would break apart. And its discoveries were so new, so accurate, that they were actually published in a peer-reviewed chemistry journal. This was a first. The first time a machine learning program had ever contributed new, publishable scientific knowledge. But the story doesn't stop there. You see, while symbolic AI was having its moment in the 70s, the ghost of the perceptron was just waiting. And then, in the mid-1980s, neural networks made this dramatic comeback. And this time, they were armed with a powerful new weapon. That weapon was an algorithm called backpropagation, championed by guys like Geoff Hinton. You can think of it as a clever way for the network to learn from its own mistakes. It sends a correction signal, a little, nope, that was wrong, backwards through all its layers. This was the secret sauce. It finally let researchers build deep, multi-layered networks that could learn way more complex stuff, blowing past the old limits of the perceptron. And the applications were just stunning. I mean, maybe the most mind-blowing thing to come out of this new wave was from a PhD student at Carnegie Mellon, Dean Pomerleau, who used one of these new neural nets to steer a car. And listen, his system, Alvin, wasn't just creeping around a parking lot. No way! It drove for 100 miles on a public highway, hitting 55 miles per hour. Remember, this was 1989. For most people, this was pure science fiction, and it proved just how powerful these new networks really were. So, this incredible comeback set the stage for the final explosive chapter in our story, the deep learning revolution that led us straight to the AI we all have today. The big moment, the tipping point, happened in 2012 at the ImageNet competition. This was a huge annual challenge to see which algorithm was best at recognizing objects in photos. And at the time, believe it or not, neural nets were still kind of on the fringe. Geoff Hinton's team was the only one using them.
The results sent a shockwave through the entire community. While the best systems out there were getting it wrong about 25% of the time, Hinton's deep learning model had an error rate of just 15%. It didn't just win, it annihilated the competition. It changed the entire field overnight.
And the result was so decisive that something happened that, as Hinton says, almost never happens in science. Even their biggest rivals, their most vigorous opponents, just looked at the results and admitted it. They said, "Okay, you were right." The revolution had officially begun.
That 2012 victory just opened the floodgates. It kicked off this incredibly fast chain of innovation. First, neural nets quickly conquered machine translation. Then came this brilliant new idea called the attention mechanism, a way for an AI to focus on the most important parts of a long sentence. That idea alone was so powerful it led to a whole new design called the transformer. Then, a new training method allowed these models to learn from basically the entire internet. You put all that together and you get the GPT architecture that powers the AI we all use today.
So, this whole 75-year story isn't just a timeline of inventions. It's really a case study in how science actually moves forward, and it's got some powerful lessons about progress itself.
Looking back, you can see these clear patterns, right? Progress came in these big waves, as one idea took over from another, only to come roaring back later. We saw key ideas like the first neural nets borrowed from neuroscience. And the biggest advances happen when they completely reframe the problem, from programming intelligence to learning it.
So, what does this whole journey teach us? Well, first, question authority. Hinton and his team challenged the status quo, and they won, big time. Second, don't be afraid to embrace a new way of thinking. And finally, a great idea isn't enough. That 2012 ImageNet result wasn't just a technical win. It was undeniable proof that forced everyone to pay attention.
And that brings us to a final, pretty provocative thought. We started this whole story with philosophers asking how learning is even possible. Well, after 75 years of unbelievable progress, the funny thing is, we still don't have a fundamental provable answer for why these systems are so good at what they do. We know that they work, but we don't truly know why. And it really makes you wonder, what amazing breakthroughs are still out there waiting for us if and when we finally figure it out?